Significant technology advances have occurred in the manufacture of iron and steel over the past 50 years, while the technology of cutting steel, a vital process for the steel industry, has remained relatively unchanged. The design of cutting torches and equipment may have improved, but the process of passing oxygen and gas through a cutting nozzle hasn't changed much in decades. Slab cutting has always been labor-intensive, hazardous, dirty, and costly. While we live in a computerized age, slab cutting seems stuck in a bygone era, where dimension control meant a man with a tape measure, and that often meant human error and wasted money. And that's not all. Current steel cutting, whether in a plate or strip mill, leaves pieces of steel residue known as burrs on the bottom edges of the cut, where they are difficult to see and remove. These burrs have the potential to adversely affect quality and cause defects in the steel unless removed. Through the years, burr removal has been a perplexing problem. It can be both a time-consuming and very expensive process. The simplest method of burr removal is called scarfing. First, the slab must be flipped over. Then the edges are scarfed, but the edges of the slab are often damaged during scarfing, raising quality concerns. Turning slabs over with a crane causes excessive wear and tear to the hoist, trolley, and ropes, and the process is so time-consuming, it's difficult to keep up with the workload. In addition, there are so many slabs in the plate mills that some plate mills avoid deburring altogether, thus sacrificing quality. Those were the frustrating facts until now. Introducing the Edward C. Levy Company's burless cutting technology. The Edward C. Levy Company, a service provider to the steel industry for 70 years, and Danze, a Levy subsidiary specializing in gas and oxygen equipment, have developed the burless slab cutting machine. This proprietary Levy process has revolutionized how steelmakers cut steel slabs. The technology is less labor-intensive, less costly, and more accurate. Above all, the burless slab cutting machine does just that, provides a burless cut. The Levy burless cutting technology is unique. Cuts are made from the back of the slab to the front, an approach never before considered in the steel industry. Cutting from back to front forces the burr to form on the upper face of the slab, and the Danze engineers designed a proprietary solution to prevent burr formation in its entirety. This proprietary solution, named the Spider, also allows for unobstructed inspection of the deburred edges during the cut. The burless slab cutting machine began operating in February 2004 at Burns Harbor, one of the premier steel producers in America. This table was designed to hold the largest slab produced. A single operator manages the cutting from a worker-friendly, acclimatized pulpit. State-of-the-art computers and PLCs allow for simple, user-friendly operation of the table. The cutting data is stored in the mainframe computer. The mainframe is interfaced with the cutting control operating computer. The table is equipped with a series of rolls with a torch between them. Lasers locate the slab however it is positioned on the table, and the rolls and the torches then adjust for the cut. Here's how it works. A slab is loaded on the table with a crane. The cutting chariots are generally positioned where the cut will take place before the slab is lowered. Security plates, however, protect the rolls and torches from damage as the slab is set down. The operator enters the slab ID number into the computer. The table elevates to allow the slab to rest on the rollers, thus permitting free movement of the cutting chariots. Lasers locate the slab and measure it for position and accuracy. The rolls and torches move under the slab to their precise cutting position. As the table elevates, the lasers confirm that the table is in the proper position for the cut. The table then tilts to the vertical position. The torches ignite automatically and move to the slab edge for preheating and cutting. the deburring bar containing the proprietary spider nozzles engage, ensuring a burless cut across the entire slab surface. After the slab is fully cut, the torches automatically extinguish, reducing energy costs, and the table returns to the offloading position. The precisely cut slab pieces are removed and are on their way to the rolling mill. This two-table operation can cut 90,000 tons of steel per month in various thicknesses, ranging from 4 to 12 inches, and additional sizes can be designed into any future machines. Consider these other advantages to the Levy burless slab cutting machine. As many as 5 child slabs can be cut in a single operation. It is impossible to cut a slab off square, because the foot rolls that support the slab while it's vertical are 90 degrees perpendicular to the track of the cutting torches. The PLC and computer controls monitor to an accuracy of 1/16 of an inch on cut pieces. The cut width has been reduced to only 1/16 of an inch, significantly improving yield. Productivity monitoring, a vital tool to production management, is built into the system, facilitating continuous improvement. Steel grades sensitive to thermal shock cracking can now be cut at significantly higher temperature, avoiding plate or strip edge cracks. Above all, a burless, dimensionally accurate, and perfectly cut slab is produced at much lower costs. The Levy burless slab cutting machine is revolutionizing the steel cutting process. Levy, applying technology to streamline steel making.